Hello everyone. This is a review for the KSAT test. It stands for Korea Scholastic Aptitude test. Uh, the exam takes place once a year on every November for the high school student who wants who want to uh, admit to university. Okay. This time I want to review the geometry math problem admission class for 2024. Um, Geometry subject is optional. This problem is number 29 for all the type. This is about hyperbola. Okay. Here I want to give you a point of this problem and what is the point and how to approach. I'm not gonna give you a full detail of uh, the logic to get answer. Rather, I want to give you a big picture and what it means on each point. Okay, so the first point, this is about the hyperbola. 2 points are on the hyperbola. Okay, it has a major axis 6, so we can we can simply draw any hyperbola uh, which is symmetry with respect to y-axis here. There are two foci, f and f prime, and two hyperbola separate curve, goes like this. And the point P, the first one, uh, is about length. This whole the point of this problem is about length, circumference, and major axis of the length. Length of the major axis is 6. And let's say we have a point P on the first quadrant here, and then we can draw a line from to each foci here. One is longer than the other one. For example, say the length of line segment PF is 4, and then the length of the longer one, PF prime line segment, should be 4 plus length of each major axis. So from the first major axis is the line segment on the x-axis between two x-intercept. This is major axis whose length is 6. I'm sorry. And in this case, the length of distance of line segment P f prime should be 10, because always in case of hyperbola, for the point on the hyperbola, the length difference from two foci, one is longer and the other one is smaller always. The length difference is always constant. The length of major axis. This is the first point. And for the second point, this is a minor one. the other point Q is on the line F prime P, and think about it. The hyperbola is a quadratic form, like x squared over a squared minus y squared over b squared equals 1, and its positive focal point x coordinate is square root of a squared plus b squared in this case. And just think, the line equation, f prime p equation, is something like this: y equals like mx plus n, mn are constant. So if you try to solve those system of equations, you'll get at most two distinct values, because it's quadratic with respect to x or with respect to y. Okay, so the point P and Q are both on hyperbola and on line f prime p. So this is all the point that we have, which satisfies this condition, the point P and Q, and the point Q is on the line PF prime. Okay, and let's try to figure out the value of C satisfying those two conditions, B and C here. Let's draw some pictures first. Okay, let's see the condition B. It's about triangle P, F prime, and F. So there are, I'm gonna simplify the picture to foresee F prime and F here. And on the first quadrant, the point P is on the hyperbola, and it is also on the first quadrant here. So the hyperbola goes like this. Okay, and we can draw a triangle like this, and it should be isosceles triangle. So how many cases we have? First think, maybe those two sides are the same. And do we have another case? Let's just say b dash 2 to foresee f prime and f. What do we have? F prime, and there might be the other third side, maybe like this. This point P is still on the first quadrant and also on the hyperbola. And then we can construct the isosceles triangle PF prime F. Okay. And this is all because those two sides cannot be the same, because as I said, uh, there's always there's always a positive difference. Each difference is always 6, so that means the length of PF prime and PF cannot be the same. Okay, so uh, the two cases are the whole thing that we have. And okay, let's go to the condition C. Point Q is on the line f prime p and also on the hyperbola. So the point Q should be here on the case B, and in the case B dash 2, the point Q should be here. Let me massage a little bit here, better. It looks better. And let's draw the triangle PQF here, this triangle. And their size, let me give them a name, E, F, and G. E, F, and G here. So do the same thing. The length is E, F, and G here. Okay. And luckily, we know that in the case of B, this length is 2 times C, because we have a specific x coordinate here. So the length from F prime to P should be 2 times C. Okay, so this length should be 2C minus G. Okay, and all the time we have for the triangle PQF, their circumference is E plus F plus G. And by the property of the hyperbola, for the point on the hyperbola, we know that the f is 2c minus 6, because for the point P on the hyperbola, the length line segment is 2c, and the shorter one is 2c minus 6. And likewise for Q, which is on the hyperbola, I give it a name of length 2c minus g here, and then this is a longer one. Original name is E, and this one should be 2c minus g plus 6, because this is longer one. So by combining all this, f is 2c minus 6, and the length E is 2c minus g plus 6. Okay, and plus g. This should be 28. Luckily enough, the g disappears, and we have 4c equals 28, because there's another elimination of 6. So c is 7 here. And likewise, you can do the same thing for the case B-2. Let me give you a setting. here, and let's see that what we have here, the distance is 2c, and f should be 2c because it's an isosceles triangle here. And then you can do the same thing for the point P on the which is on the hyperbola. This is longer one. Okay, this should be 2c plus 6. Okay, and then for the point Q on the hyperbola, this is a shorter one. This should be e minus 6. So you can do the similar thing. Please do it yourself, and you'll get some another value, positive value c here. So those two c's are all we have, all possible value of c, and then you can add them and you can find the value. What the question is demanding you to figure out. Okay, let's wrap up this problem. The main point of this problem, the 2 points are on the hyperbola, so we have main property of this. This is same for the point Q, which is on the hyperbola. Their length of difference is constant, which is the length of the major axis. And the reason why this might give exam takers feeling of extra difficulty is that to find the all possible value of c. So it gives you a question how many cases we have. So as I said, there are only 2 cases because the point Q is an intersection point of the line and the hyperbola. So intersection point between line and the hyperbola is at most 2 distinct points. So how many? In this case, it's 2 cases. That's all possible cases. And then if you can draw the right rough picture of the hyperbola, and then without the complicated calculation, you can reach to the point. Okay, that's it. Thank you.